Hi, I'm Daniel. I make this video uh, to to get the Mac for the task Apple on sit221, and we discuss to talk about other code we got on the heap. We have two heap here, that is the max and the min heap. The max heap just it's just a the max the binary tree. The heap that means the binary tree, the complete binary tree, and we use the max heap. That means the group of the binary tree start from the max is the biggest, yeah, and the min is the smallest element. Yeah, this one. Um, the group is the max. Max heap is the biggest group, and the min is smallest group. And we have some function to work on the binary tree. And this binary tree is uh, I got it from the internet. Yeah. They use the array start from element from the zero index. But with my code, I use it from start from the index number one. So we have some different at the down heap function. But we just start from delete function. Delete function when we want to delete the element, we need to move that element to the end of the array and delete it at the end. And swap to with the element at the end. So the element at the end will go to the first place. When it's go to the first place, it's the wrong place for that. It's like number one go to number 16. It's the wrong place, and we need to use the down heap and up heap. That's like just use the right rotation and left rotation to move the node on the left and right to get it into the right lane. And the down that means it move the node into the middle or become the eternal node. And the up heap move the node from the bottom to the middle or the top. Well, with the down heap, um, we need to define the left and the right. With the array with start from zero, we need to add the plus one for the left, and the right we need to add plus two. But my code let's see, just start from the number one, so we don't need to add like that. So to define the left and the right node. So when we define it into the from the array, define the left and the right node from the array. Well, to know what's place for the right, what's place for the left. When we have that, when we are so when we did it, we will know in the array like number 16 and number 14 and number 14 here. The computer will know that's in the left, and the number 10 here, this is on the right. When we see into the array, we can write 16 and left, right, left, right, left, right, 14, 10, 8, 7, like that. Mm. With the down heap, we compare the element with the right and the left, like here. Because we have in this task we have the element and the key to modify to compare, because our values is in the name, so we need the key in number to compare that. um, then after we compare that, we will know um, the position need to move to the right or the left, or keep it there and compare with other node in the binary tree or not, to move it to into the right place. And the period, that means just the loop statement to add the value into the array, because we have we can't do one by one values, so we need to use the behavior to add the name and the key as a node into the long array. And when we add it like that, that's in the messy input. So we need to use the heapify. Heapify that will start all of the element as the root and internal to compare with the external of that of every node to know you use the down heap, then we use the down heap there to the internal. We compare with external. Is it in the bright light or not? This here, this is 2, 8, and 4 here. This is the bright light for that. But if the number 8 and the number 2, the place that the number 8 is the number 2 place, and the number 2 is one into the number 8. This is the wrong way, the wrong place. So we need to use the heapify to check is right or not. Now by the down heap, when then because in the down heap we have to compare to the node, is it the right place or not? Then we need to do the swap the number into the right place. And next to that, the degrees key. The degrees key we have the our code our result. We I passed all the result already, and the degrees key is now in this part we use the degree key to decrease this element David degree the key to become 0 key 0. This is 13 to 0, and this part to David not at the end already, because we delete some element. So after we delete that, we move the first element to the end to delete, and then the end will go on the first place. And after that, we use the down heap already. So the element, the order of the element here, not like the first array anymore. So we're here to David display, but we define it into another variable. We save it into another variable to know what element we need to retrieve the key. And after we retrieve key, and we use the upheap because it's display in not the right place, because this is number 13. When we retrieve into the number 0, it should be at the first place, like right here. So we need to use the upheap to move it into the first place in the array, the first index. For the upheap, let's see from the code I got when I start with this library. So it just do the compare, same with the down here to compare it, the compare it with the from the external, compare with the internal to know is it larger larger or smaller. Do we need to swap or not, and move it into the right place. Now go to the Happify already. The delete now delete element. It just is the same with the delete. The delete do the same way, but with this one we need to take the element was element like this on. This might be the external or internal. We just move that into the right the end and delete that. And after that, we need to use the down heap for the element we swap. Like number one, we swap with number 8. We delete number 8 right there. So number one right here, we need to use the down heap to move it to become the eternal because it's the monolith. Yeah, it's become the eternal node and the main element that came in. This one, uh, this one we use to let me see. I forgot that. This one we use to do minute here. We delete the node with the fourth place in the array. Yeah, we use to find the element at at the in the array. Like we give the position. We need to delete that number four. The fourth. So because my array start from number one, so number four here is just the number three because we have right here. This here is the number one, and here's the number two and number three. So I still have the number zero right here. So that's why in my course that it shows zone here. Just we can see here just number three. That's why here four and here three. Um, and we just move the element here into another array, and we delete it. We take this one. We take this one into the another. Oh, take this one out, and we put the value back to the current array. And when we know this position, the fourth position here, it is this element, then we can sort it out. And how easier we can see on the code right here. So just we have to, this one to return, and this one to temperature remove. We will move the, the index into the temp. Then we find out the join element. Then we put it into the k-min here to return, and the element into the temperature array right here. We will use to insert it back to the current array. That's it. And my course follow with the datasheet. I need to do some complexity, and I mark down here on the code for you to see. I've I did it and follow with the datasheet like that.